All right, section 8, we're going to look at complex numbers. And we're starting out with complex numbers, talking about this imaginary, what we call the imaginary unit. This imaginary unit that we label as I is defined so that I squared is equal to -1, which therefore makes the value of I the square root of -1. So what this does is this will allow us to deal with those situations where we get a negative underneath the radical. So if we look at this square root of a negative number example down here, if I have something like the square root of -5, notice that I could write that as the square root of -1 times the square root of 5, and the square root of -1 is I, so it becomes I times the square root of 5. So we're going to use that concept to simplify these radicals that have negatives. So if we want to simplify the square root of -18, we're going to think of that as the square root of -1 times the square root of 18. Well, the square root of -1 is I. 18 is 9 times 2, so that's square root of 9 times square root of 2, and the square root of 9 is 3, so I get 3I times the square root of 2. So if we look at square root of -12, that would be square root of -1 times square root of 12, which gives me I, and the square root of 12 simplifies to square root of 4 and square root of 3, which gives me 2I times the square root of 3. Square root of -7, that's going to be I, which is, back up a little bit there, it would be square root of -1 times the square root of 7, which becomes I times the square root of 7. And square root of -25 would be square root of -1 times square root of 25, which becomes I times 5, but we just rearrange that and make it 5I. Okay. So whenever there is a negative, we can remove the negative, convert that to I, and then simplify the positive number left under the radical. We want to focus on these called complex numbers. Okay. A complex number is in this form of A plus BI, where the A is the real portion and the B is the imaginary, what we call the imaginary portion. Okay? And the complex numbers are just a portion of what encompasses these real numbers and these imaginary numbers. Okay? If B is 0 and there's no I, then I have a real number because I only have the A portion. And if A is 0 and I only have the I, then we have what's called a pure imaginary number. So one of the things we're going to look at with these complex numbers is doing operations. And we can define the operations on these complex numbers so that we can do addition and subtraction, okay? Or we can do multiplication and division. So we're going to start out here by looking at adding and subtracting complex numbers. And it's really nothing more than combining like terms, okay? So when I'm adding and subtracting complex numbers, I'm adding or subtracting the real portions, and I'm adding and subtracting the imaginary portions. So 4 minus 3I plus -4 plus 3I, I'm going to combine 4 plus -4, so that's this first portion here. And then I'm going to put together the -3I and the positive 3I, that's the second piece, okay, using the commutative and associative properties. Well, 4 and -4 is 0. -3I plus 3I would also be 0, so the whole thing turns out to be just 0. What that tells us is that 4 minus 3I and -4 plus 3I are what we call additive inverses, because when I add them together, they zero out. In example B, okay, notice we've dropped the parenthesis, we've changed our subtraction, we've distributed the negative sign here, and that's how we're getting this +2 and this -4I. And then we're just basically combining like terms. 5 plus 2 gives me 7. And the -3I and the -4I, we're putting those together and getting the -7I, giving us our entire complex number of 7 minus 7I. All right, so let's look at example A here. We're going to basically combine like terms. I'm looking at taking 7 plus -3, which is going to give me 4. and I've got negative 2i plus 1i, which is negative 1i. So I have 4 minus I as my complex number. Part B, I'm going to take 1 minus 3, which is going to be negative 2, and I'm going to take 5 minus negative 2, which becomes plus 7i. The other option there would be, remember, we could distribute that negative. So we'd have minus 3 and plus 2i, and then combine our like terms. 1 minus 3, 5i plus 2i, and I still get the negative 2 plus 7i. So adding and subtracting complex numbers is really nothing more than combining like terms. Okay. Multiplying. We can multiply complex numbers the same way we would multiply any other binomials or monomials by using distributive property. So in example A, I've got 3i times negative 5, that would be negative 15i. 3i times 2i would be plus 6i squared. But we have to remember that I squared is really negative 1. So I have negative 15i minus 6, and I put it into the standard form, which is the real portion, negative 6, minus the imaginary portion, the minus 15i. And there's our final answer. In example 2, we take 4 times negative 1. 4 times negative 2i would be negative 8i. 3 times negative 1 is minus 3i. And 3i times negative 2i is minus 6i squared. So when we combine like terms, I've got minus 11i. Remember, I squared is negative 1. So I have negative 4 minus 11i, and that becomes plus 6. And now these are like terms, so I have 2 minus 11i as my final complex number. And example C, negative 6 times negative 6 would be 36. That's going to be a plus 6i. I'm going to get a minus 6i, and I'm going to get a minus I squared. My plus 6i and minus 6i are going to zero out. So I have 36 minus, remember I squared is negative 1, so it becomes 36 plus 1, which gives me 37. So we'll look at some more of these examples of adding, subtracting, and multiplying, and we'll get some more practice with these in class tomorrow.